so very long ago, as late as 1966, anyone crossing the Kiskörei Tisza bridge could still admire the characteristic Tisza country, although at that time the new altered features of the landscape had already taken shape in the engineer's plans. Most people hadn't realized yet that the biggest and most important project of the development of the Tisza basin, the Kiskörei water lift, would be constructed in this region. The determination of the site of the Kiskörei lift was preceded by a careful study of several alternatives. The lift had been envisaged in the area of Tisza-tó and Tisza-bura at the beginning of the 1950s. The investigation and weighing of the various factors resulted finally in the decision to construct the lift in the vicinity of Kiskörei as the most economical solution. In 1965, the Economic Committee decided about the realization of the lift and the first building phase of its irrigation systems, as well as about the commencement of the construction in 1967 and of the damming of the Tisza in 1973. Hydrological, soil mechanical and geodetic preparatory operations preceded and planning the construction of the lift. Answers to questions of stressing and hydrology arising in the course of the designing were provided by model tests. On the basis of the drawn-up working plans, the site was marked out, which, however, required a network of reference points and reference data of great precision. The embankment surrounding the working pit of the lift was begun in late 1966, and this marked the beginning of the operation. The 1,400-meter-long circular embankment was designed to keep out the Tisza floodwaters from the working site. At the start of the building operations, Under-Secretary Imre Degen, chairman of the National Water Board, toured the site in the company of the General Staff of the construction. The investment work was taken care of by the National Hydrological Investment Enterprise, which set up a special investment engineering agency and a local bureau at Kiskörei. The Hydrological Design Office, the general designers of the main construction work, established a chief engineering agency in charge of operations to direct and coordinate designing work. Besides the hydrological construction enterprise and the Groundwater factories, more than 100 firms and other bodies took active part in the construction. No sooner had the building of the circular embankment started than the early spring flooding of the Tisza caused difficulties and greatly interfered with the building operations of the embankment. Unfortunately, during the 7 years of construction, the floods several times threatened the working site, and the big flood disaster of 1970 also occurred in this period. Flood control, in which, if necessary, even the builders took part, was directed by the Central Tisza Water Management. The preparatory construction work was begun in 1967. This included the building of the concrete road leading from the village of Kiskörei to the working site. An industrial railway line with worksite sidings of a total length of 3.7 kilometers was established and linked up with the open track. The sidetrack enabled the rail transportation of large quantities of building materials and steel structures. It shows how much circumspection was exercised that a large part of the permanent establishments was scheduled in a way that they were suitable for procession purposes during construction. 120 flats and a bachelor hostel for 110 persons were built in this way. They were both used as workers' hostels. Most of the stores and workshops were housed in the permanent auxiliary and factory buildings. Drinking water was laid on, and a sewerage system and a sewage farm were established. To provide hot water for heating the buildings and to supply hot water, a caloric center was built with an output of 4.5 million kilocalorie per hour. A self-service general store was established for the workers. The workers and the employees had eating facilities on site in the permanent restaurant, seating 1,300 persons. Scraping technology was employed to excavate the earth from the working pit. At the lower levels, however, the earth movers got stuck in the mud, and the difficulty had to be overcome by the use of mining conveyor belts. A groundwater surface decreasing system was established in the working pit because of the vicinity of the riverbed of the Tisza. The system was gradually extended as the 600 cubic meters of earth were removed. In the first step, a series of filter wells, in the second a series of vacuum wells, and in the third a system of deep wells were used. The groundwater surface decreasing system ensured the undisturbed construction work even during the flood. In order to decrease the ascensional power acting on the sub-base of the lift and the seepage under the engineering structure, a bulkhead closure was made on the upstream side. Because of its low cost, a concrete wall was built for this purpose, which besides preventing seepage also served as the foundation of several parts of the lift. At first, the cutting was done by a T150 titania cutter. Later a fourth pressure titania was employed. The cave-in of the wall was prevented through filling into the cut a specially composed slurry worked out before the start of the construction. Approximately 10,000 cubic meters of concrete wall was built, whose quality was checked by various tests. With the start of the cutting work, increasing amounts of concrete were needed, and therefore twice 500-liter mixers were put into operation. This concrete mixing plant operated outside the working pit near the housing estate. After the beginning of the massive concreting work, the small concrete factory produced concrete made of 600 cement arriving mainly in bags. The Hungarian Young Communist League undertook sponsorship of the building of the Kiskörei lift. The Central Committee of the Young Communist League, the Ministry of Agriculture and Food, and the National Water Conservancy Board concluded in May 1968 a socialist agreement to complete the construction of the lift by the deadline and to promote the utilization of the irrigation water. At the initiative of the Young Communist League, the investing, designing and executing parties involved in the realization of the lift, as well as the youth movement organizations, laid it down in 1970 in a socialist agreement that they would cooperate in ensuring the continuous and unimpeded construction of the project. It's characteristic of the scope of the sponsorship that close on 1,000 Young Communist League organizations throughout the country were mobilized to achieve the objective. In the course of the construction, more than 150,000 cubic meters of concrete were needed. This meant that there was 1 year when 50,000 cubic meters of concrete had to be produced. An automatic concrete plant of 30 cubic meters per hour output set up in the working pit near the barrage ensured the necessary concrete for the lift, as well as occasionally for other constructions nearby. The fractional aggregate was taken to the 100 cubic meter capacity feeding bunker by way of a 1 cubic meter loading machine and conveyor belt. The high-capacity conveyors and the 120-ton storage bins continued for a long time to be characteristic features of the construction site. Four Polish-made tower cranes moved parallel with the axis of the lift on the upstream and downstream sides. The four tower cranes were able to carry the 1.4 cubic meter capacity concrete containers to any point of the huge structure. The giant cranes marked the site of the construction from a long distance from the plain. The groundwork began with the making of the sub-base of the power plant, formed out of 26 concrete slabs. The groundwork level of the power plant was situated lowest, 6 to 7 meters below the ground level of the dam and the navigation lock. This circumstance caused some difficulty in dewatering. However, this difficulty too was solved by installing catchwater drains. The generally 6 by 6 meter caskets at the sub-base were made using delta-plated shuttering. Special arched cradling ensure the favorable hydraulic features of the turbine cylinders. Plywood was used for the arched cradling. After the completion of the sub-base, the construction of the concrete bodies of the wheel pits began. Both the iron fitting and the concreting were rendered difficult by the very close steel reinforcement made according to the plan. The surfaces of the wheel pits were made abrasion resistant because of the high water velocity during operation. the 12-meter-high inlet wheel passage of favorable hydraulic properties. After the construction of the lift, the mainstream of the river changes, and thus the banks below the lift had to be strengthened. This work was carried out by traditional methods. River regulation had also to be undertaken along the upstream stretch above the lift, partly because of the change in the water level, partly for the development of river navigation. The 120 million forints worth project was already carried out in the main by the up-to-date beam lattice method. The work on the new riverbed outside the circular embankment was started in 1969. This meant moving some 2.8 million cubic meters of earth. The earthwork was begun first with scraping and dredging technology, then the formation of the new riverbed was completed by hydromechanical excavators. The removed earth was used to fill up the tracks outside the old flood control bank. The groundwork of the barrage was made according to the same technology as was applied at the power plant. The 3.2-meter high streamlined sill of the barrage made it possible to substantially decrease the dimension of the flood. The radial gate employed at the barrage enabled the width of the pillars to be decreased to such an extent that the slender pillars made this way can be considered to have practically the smallest feasible dimension. At the peak period of the construction, which occurred in winter, 6,000 to 8,000 cubic meters of concrete were used. With appropriate measures, double wall shuttering and preheated concrete, it was possible to ensure the faultless quality of the concrete even in winter. Building proceeded with new technology, thereby saving costs and labor and increasing productivity. The new technology was also necessitated by the shape of the pillars. The big paneled cradling method was advantageous in the building of the pillars. The self-supported wooden panels of 2 by 3.5 meters were placed alongside and above each other. It's characteristic of the building technology that the formwork panels were used not only for the 20-meter high piers, but they were later used for the lock and the key piers too. so-called fishtails of the piers were formed out on the basis of model hydraulic tests. They enabled the tail race to be shortened. The building construction of the hydroelectric power plant was made by essentially traditional technology from monolith reinforced concrete. Above all three stages of the lift, a crane runway was erected. The movement of steel structures, the fitting work, as well as the purposes of the operation of the dam are served by two frame cranes of 40 per 10 megatons designed by the KGM designer. The making of the riverbed surface linked to the dam would have been very labor and time consuming by the traditional method. Therefore, a new procedure was introduced, the so-called beam lattice natural stone masonry flagging. This procedure enabled the covering work to be completed in the short time available. In the immediate neighborhood of the lift, a novel and attractive concrete covering was laid out. The management office of the lift was built last among the establishments on the shore. When the construction of the power plant and the barrage was well advanced, the building of the navigation dock was started in 1970. The navigation lock was constructed with as little concrete as possible. Still, 35,000 cubic meters of concrete had to be built into it. Hollows formed in the concrete structure of the lock and the adjoining weirs were filled with material obtainable on the spot. The shapes of the barrage, tail rates, the energy breakers and their positioning were determined by model tests. They are now effective in upper or lower water discharge alike. The segments responsible for the main blocking of the dam and the working cylinder activating it are supported by the pins on the piers, which had to be made very carefully because they are exposed to extremely high power impulses. The segment and the tip panels manufactured by the Gunsmark factory were transported by trailers to the spot in carts where they were mounted. The cloughs are operated by an up-to-date 160 atmosphere electro-oil hydraulic equipment. Once the concreting work was well advanced, the filling up of the trench could start. This required a very high degree of packing. A lot of work is to be done yet, but the main components of the lift are completed, and the entire project is beginning to assume its final shape. The new riverbed had also to be formed within the circular embankment, so that at the subsequent cutting across of the riverbed, only the demolition of the circular embankment should remain to be done. This was of course preceded by the pulling down of the concrete plant. The steel structures, as well as the bulkheads operating as temporary cloughs, were also transported to the site. The annual 103 million kilowatt per hour energy produced by the power plant reaches the 20 kilovolt network through the intervention of two transformers. The mounting of the electro-hydraulic actuating equipment was directed by the engineers and fitters of the Hossza hydraulic manufacturing firm. The completion of the lift enables the water to be let into the new river. After the removal of the groundwater level decreasing system in June 1972, the demolition of the circular embankment was begun. In the first phase, a 30-meter wide canal had to be dug on the upstream and downstream side. However, in spite of the fact that the groundwater level decreasing was stopped, the water failed to rise satisfactorily in the working pit. The working pit was filled with water with the help of a floating dredger in order to equalize the water level on either side of the circular embankment. The cutting across of the circular embankment could only take place after this. In the final formation of the riverbed, solid grabs were also used. These grabs had been primarily introduced to unload the great quantities of stone used in the building, which was thus completely mechanized. For the express purpose of loading stone, Vízlép had manufactured 5 hydraulic solid grabs. With the circular embankment cut across, the flooding of the dam has taken place. This operation was carried out by excavators above the water level and by floating dredgers under the water. The river Tisza has found its course in the new bed. This was the time when the water flowed in two beds, and the work on obstructing the old riverbed could be undertaken. A temporary bridge became necessary on the left bank on the downstream side of the lift in the interest of cutting off the old riverbed. After scar protecting by faggots, the piles of the makeshift bridge were rammed down. In the interest of the riverbed closure, the entire cross-section of the Tisza was blocked by a stone dam of 5-meter crest width. The building of the dam was begun on the side of the lift, and the last 48-meter-long section was erected from the temporary bridge. In building the bridge, the same twin steel supporters were used as had been earlier employed in the construction of the crane runway and the factory bridge. The bridge was mounted on the piles in 3 days. An important stage was reached exactly on schedule. At 7 a.m., the 27th of September 1972, the cutting off of the still free stretch of the riverbed had got underway. 1,200 baskets of stone weighing 1 ton each were tipped into the Tisza on the downstream side, while simultaneously stone throwing was employed on the upstream side. Under-Secretary Imre Degen and his party appeared personally for this important event. "25,000 cubic meters of stone were used for the blocking up of the riverbed. It's characteristic of the good organization that the work was completed in 22 hours instead of 3 days originally scheduled. As a protection of the stone dam, the old riverbed was filled up with earth in a length of 280 meters. 400,000 cubic meters of earth were needed for this purpose, most of which was ensured by hydromechanical way. Man has triumphed once again over nature and forced the unruly Tisza into a new day. On the 16th of April, 1973, the segment-shaped sluices of the barrage were lowered, and with this the preliminary operation has begun. The trial operation was already performed by the experts of the operating Mid-Tisza region water management under the direction and control of the designer. The undisturbed functioning of the equipment has to be checked during the preliminary operation, and the guarantee measurements have also to be carried out. On May 16, 1973, the Kiskörei lift, gaily decorated with flags, received hundreds of celebrating people arriving in convoys of cars. It was a momentous event, not only for the national water management and agriculture, but also for the country as a whole. After the address of Undersecretary Imre Degen summing up the results of 7 years of construction work, Jenő Fok, the Prime Minister, officially inaugurated the Kiskörei lift. Where a few years ago pastures stretched on this site, today there are new irrigation canals crossing the fields and hundreds of sprinklers spray the life-giving water of the Tisza. Another in the series of our national projects, the Kiskörei lift, together with its irrigation system, has been realized in the building of socialism in Hungary, proclaiming the strength of our people.